Hello, welcome to Maths Kitchen. I'm James. We're nearly there. 2 exams down, final one to go. And in this video, I'm going to be going through topics and questions that I think are highly likely to come up in that final exam. And as with my previous videos, if you've seen those, I've put up some questions on mathskitchen.com, my website, that will help you to practice all the things that I'm mentioning today. And as with those previous videos, this is not really a prediction. I haven't seen the paper. I don't know what's going to come up, but these are things that do tend to come up year after year. So very likely to come up. And certainly if you're looking for a last minute bit of revision, just something to calm your nerves and keep you a little bit focused in that final run into the exam, I think these are a really good place to start. So don't forget to go and have a practice at mathskitchen.com. I've done these videos before for the paper 1 and paper 2, and there were some things that I said I thought were highly likely to come up in those papers that haven't come up yet, and you can see those there. And I think if they haven't been up yet, there's every chance that they're going to come up in this final paper. So those are my first recommendations. And then for the rest of the video, I'm going to go through these other ones as well. And I'm not going to go into great detail, but I will give you some little tips and tricks for each of those question types and some little mistakes to avoid and that kind of stuff. So before I get into the new stuff, let's see what I had to say about the ones that I'd already covered. Speed and density are 2 examples of what we call compound measures, where you're combining 2 different measures. So speed, for example, is you're combining distance and time. You know, how long does it take you to go a particular distance? Density is the same. We're combining mass with the size of something. In other words, what is the mass for a particular size? You know, a piece of wood might be 0.6 grams for every cubic centimetre of wood. So if it's a speed question, you may well be asked to find an average speed, or you might be given an average speed and you need to use that to calculate a particular distance that someone might have travelled on a journey, something like that. My tip for these is to try, at first at least, to use a kind of common sense problem solving approach. So just remember that speed is just a measure of how far you travel in a particular time. For example, 80 kilometers per hour just means in an hour you would travel 80 kilometers. So you may, just by bearing that in mind, using a bit of common sense, you may just be able to problem solve these questions without going straight to using a sort of formula, or maybe a formula triangle some people use. Those are fine ways to solve these as well, but my first port of call would be to try and just sort of problem solve it using a bit of common sense. And then secondly, when you have your answer, use a bit of common sense again and just think, does this seem about right? You know, that maybe you've worked it out, somebody's walking 2,000 kilometers in an hour. You know, that's you've obviously made a mistake there. So just at the end, double check, does this seem like a sensible answer? So the second thing, compound interest. So this might be a reasonably straightforward question where, you know, they might give you 2 different offers that a bank is making with, you know, different interest rates, and it's asking you to compare those things. And if that's the case, it's a reasonably simple process. You might find it useful to use a multiplier. So for example, if you want to increase something by 18%, you multiply by 1.18, and that will increase it by 18%. If you want to do that over multiple years, so let's say something is going to increase by 18% every year for 3 years, you would multiply it by 1.18 cubed to the power of 3. And however many years you are doing it for, that determines what your index number is. Which brings me on to the second way that they might ask these kinds of questions, and I'll illustrate this with an example. So they might say that somebody has invested £12,000 for 3 years, and at the end of that 3 years they've got £13,891.50, and we've got to work out what the interest rate was for those 3 years. So we remind ourselves of how we would calculate this using a multiplier. So what we would have done would have been 12,000 times something cubed, because it was 3 years, and the answer that would give us is 13,891.5. So now we've got an equation that we just need to solve. I'm using x to describe that multiplier, So to find out what x is, we would divide both sides by 12,000, and that will tell us that x cubed is equal to 13,891.5 over 12,000. And then we need to do the cube root of that to find out what x was, and that gives us 1.05, and 1.05 represents a 5% rate of interest. Next up is histograms, and here's what a histogram looks like. This is an example of a histogram question. They could obviously ask you these in different ways, but often what they want to test is that, do you understand how to find the frequency from a histogram? And to find the frequency, you have to find the area of each bar. So that is the big thing that you need to remember with histograms. To find the frequency, you multiply the width by the height. In other words, you find the area of each bar. Next up is laws of indices, and this is one of the ones that really it could just as easily have been in the non-calculator paper, but it didn't seem to come up. And I'm talking about questions of this form, where you need to understand that when you are multiplying numbers together, the index numbers just get added. Okay, so reasonably straightforward. It's just kind of remembering those rules, isn't it? So that is it, laws of indices. The final thing I would suggest is iteration, which can be a bit off-putting because of the way that the questions look, and the mathematical symbols and language that is used can be a bit off-putting. But I think actually these aren't as bad as they look, and it's worth spending a bit of time trying to get to grips with them. Even if you can't do the whole question, there may well be a big chunk, 2 or 3 marks that you could do pretty easily. So here is what a typical question looks like. This is taken from 2017 Edexcel. So you can see it says, using x n plus 1 is equal to negative 2 minus 4 over x n squared, with x0 equal to negative 2.5. Find the values of x1, x2 and x3. So it looks terrible, but really it's not that bad. All you're doing is substituting numbers into a formula. So you can see where it's got that xn squared in the denominator of that fraction. You're going to substitute numbers into that, and you're going to get an answer. Then that answer is the bit that you substitute back in next time. So it's saying to start with negative 2.5. So we're just doing this on a calculator. I need to type in negative 2 minus 4 over negative 2.5 squared into the calculator. When you're squaring negative numbers on your calculator, you must put them in brackets. Otherwise your calculator works it out slightly differently to the way you think it will. So you must do that. Then you can see if I hit equals, it gives me the answer there, minus 2.64. All I've got to do, so that's the first answer. The second one, all I have to do, I'm going to go and replace that negative 2.5 with the answer that I just got. In other words, with negative 2.64. So I go back, type that in, hit equals, and that gives us our second answer. And I need to then put that back in, and that will give me the next answer. So that's a little bit of a mouthful, isn't it, that answer there? So I'm going to do this little trick, which is I'm just going to go back in, delete the previous one, and I'm just going to press that ANS button. And that will put in the previous answer for me. Press equals, and I get the final one. So that is it. That's how you do those. And that was 3 marks for that part of the question. So if you think of it, it's just substituting numbers into a formula, but then your answer gets substituted back into the same formula, and then that answer gets substituted back into that same formula. You just keep repeating that process. That is iteration. So not quite as bad as it might at first appear. Okay, those were the ones that I'd previously thought might come up in paper 1 or 2 and didn't. What about the other things that I now think are likely to come up? Let's go through those one by one. Percentages is highly likely to come up in this final paper, and there are different things that they might ask you. Things that I would focus on at this sort of late stage for your revision are being able to do reverse percentages, being able to calculate the amount of profit as a percentage, and tied in with that is being able to find one thing as a percentage of another. Okay, so let's say 500 people out of a total of 650 pass their GCSE exam, and you are asked to describe that as a percentage. The way I think of that is as a fraction. 500 out of 650 passed their GCSE exam. So that is what it is as a fraction. To convert that to a percentage, I just need to multiply that by 100. So you can do that on your calculator. 500 over 650 times 100, and that tells you what 500 is as a percentage of 650. Calculating a profit as a percentage is the exact same thing. It's the amount of profit over the starting amount, the amount that you initially invested, if you like. So that's percentages. Simultaneous equations are likely to come up, and my tip for these is at the end, when you finish, you can go back and you can substitute your answers into both of the equations. You have to substitute the answers into one of the equations to have got both of your final answers, but then substitute them into the second equation just to check that they work in that equation as well. And if they do, you can be very confident that you've got that answer correct. If they don't, you're going to have to go back and just see if you can find out where that mistake is. And then the other thing with those is to be really, really careful with negatives. Don't forget, when you're subtracting a negative number, it has the effect of adding that number on. So 9 take away negative 3 is the same as 9 add 3, so 12 in other words. And that situation comes up quite often when you're dealing with simultaneous equations. So keep that in mind, and those are my tips for simultaneous equations. Upper and lower bounds, this is all about asking yourself, before this number was rounded off, what's the very most it could have been so that it would still round off to this particular number? And what's the very least that it could have been so that it would still round up to this number? So let's say a number has been rounded off to the nearest 10, and once rounded off to the nearest 10, it is 40. The smallest that that number could have been initially was 35, because any smaller than 35, when you round it off to the nearest 10, well, we would round it down to 30 if it was smaller than 35. So 35 is the lower bound, and then the upper bound would be 45, because 45 or bigger, and we would round that up to 50. So 45 shows you where that boundary is, but it can't actually be 45 because we would round 45 up to 50. So we say the upper bound is 45, so it can go up to, but not including 45. One common way of asking you questions to do with bounds is to give you a formula, and you've got to substitute numbers into that formula to find the lower bound. In other words, to find the smallest possible number. And if you think about a fraction, just a numerical fraction with numbers, and let's say you've got two numbers, 3 and 4, you've got to work out which one goes on the top and which one goes on the bottom so that you get the smallest possible number. 3 divided by 4, 3 over 4 in other words, is going to give you a smaller answer than the other way around, isn't it? 4 over 3. So just bear that in mind. Think of a numerical example when you're doing those bounds questions and they've given you a formula to substitute into. So to get the lower bound, you want the smallest number divided by the biggest number. And if they've asked you to find the upper bound, you want the largest number divided by the smallest number. You could think of it, you want the most amount of sweets divided between the smallest number of people. That will give you the biggest answer. Questions to do with spheres and cones come up quite often, and in fact what these questions are really about is working out whether you understand how to use a formula correctly. So it might just be that you have to substitute numbers into the formula where you've got some squared or cubed terms, and just making sure you can do that correctly, and then sometimes having to rearrange it. So for example, for the volume of a sphere, you might be given the volume and then you have to work out the radius. So in those situations, I would put in all the numbers that you've been given, and then you're just trying to solve an equation really. You're trying to make R, in this example, the subject. And you just need to make sure that you follow the steps that you would do when you're solving any equation. Always do the same thing to both sides. Angles in polygons is a question that comes up often. And with these, I tend to just go back to basics and I remind myself of the fact that I know, and I build up a picture from there. So I know that the interior angles of a triangle add up to 180 degrees. And the interior angles of a quadrilateral, a four-sided shape, add up to 360. And that reminds me that from there I can kind of work out, right, yeah, they go up by 180 degrees each time. So for a pentagon, a five-sided shape, I'm going to have to add on another 180. So that would be 540 degrees. For a hexagon, it's going to be another 180. So that would be 720 degrees. And I tend to sort of problem solve it from there. So for example, in a hexagon, we know that the angles are going to add up. The interior angles are going to add up to 720 degrees. And so therefore, we can work out the size of each interior angle because it will be 720 divided by 6. So interior angles of polygons. Quadratic simultaneous equations, now into sort of meaty stuff towards the end of the higher paper, aren't we? And with these, it's really important to remember that you will get two pairs of answers. You will have an x and a y and another x and a y, and you can just think of those as pairs of coordinates. And as with the simultaneous linear equations, your answers should work in both of the equations. So you can always substitute back in and check your answer that way. Venn diagrams, there are two really key skills that you need here. And one is really just understanding the language that is used. So the key things I would say to remember are that kind of U is talking about the union of two things. And that means everything that is in both of those groups. And then the other one that looks like that is the intersection of those two groups. And that is the place where those two groups overlap. So I'm going to fill in the numbers on this Venn diagram. So it is to show all even numbers between 1 and 25. So we must include every single even number. And let's start with A. So we've got 2, 8, 10, and 14. Well, 8 also appears in B, and in fact it also appears in C. And it's the only number that is in all three of them. So that goes right in the middle there. The other three numbers, 2, 10, and 14, only appear in A. So let's write those in there. For B, we've already written in the 8. And then we've got 20, which also appears in C. So let's write that in there in the intersection between B and C. And then we need to include the 6 as well. That is only in B. And then for C, we've already written the 8, we've already written the 20, and then the two remaining are 18 and 22. But this Venn diagram must represent all the even numbers between 1 and 25. So the ones that don't appear in A, B, or C, we put those outside there. So we've got 4, 12, 16, and 24 that we also need to include. Sine and cosine rule. There are two key challenges to this, I think. Firstly is remembering those formulas, and then secondly is knowing when to use them, or when to use which one in particular. So when we use them, well, we use them with non-right angled triangles. And when to use each one, well, the cosine rule you use for two situations. Firstly, if you've got an angle in between two lengths, okay? I think of that angle as being tucked in nice and cozy for cosine, in between those two lengths, or if you've got all three lengths. So cosine rule when you've got your angle nice and cozy in between two lengths, or when you've got all three lengths. And then really use the sine rule for the other situations. Other than that, you just got to try and remember the formulas. The sine rule is actually pretty straightforward, isn't it? It's A over sine A is equal to B over sine B is equal to C over sine C. That is if you're trying to find a missing length. If you're trying to find a missing angle, just flip them up the other way so that you've got the sine A on the top. And that's quite easy to remember because, you know, sine is referring to an angle, isn't it? So whatever bit you're interested in, that goes on the top. And then the cosine rule, that's a little bit harder to remember, but it is very similar to the Pythagoras theorem, isn't it? You can see there's a big overlap there. And I just remember it like that. And that is when I'm trying to find a missing length. If I'm trying to find a missing angle, I'm going to rearrange it all. and I'm going to go through these steps here. You can see I'm animating those there, going through it quite quickly. But that's why I do it. I really, even to this day, I've been teaching for goodness knows how many years, I still struggle to remember it in the form where I'm trying to find a missing angle. But it's fine because I know how to rearrange it to that, and I think that's absolutely fine to do it that way. Those are the things I think are highly likely to come up in this final paper. No guarantees, of course. I don't really know what's going to be in the paper. I haven't seen it. I don't work for Edexcel or anything. But I do know the things that tend to come up year after year, and there's a very good chance that those things are going to come up. Probably not all of them, but a good chunk of those things I've mentioned I think will come up. Don't forget you can go and practice those at mathskitchen.com, and if I don't see you again, good luck with your final exam. I hope it goes really, really well for you, and good luck with whatever you're doing after that as well.